Hello, it's Keith from Kinvert. Apologize for the video audio that's going to probably be happening here. We got people in the kitchen and yeah, not much I can do. So let's look at another example of y equals mx plus b. Now this isn't going to be a perfect example, and hopefully you'll kind of see why in a bit. But imagine you're trying to find what is a good value for a house. So this is a one-bedroom house, and this is a two-bedroom house, very nice, and then a three-bedroom house or something like that. I'm very good at drawing houses. So 3 bedrooms, 2 bedrooms, and then finally a super-duper huge 4-bedroom house. Yeah, so that works. Now imagine if we look around and we find that the average one-bedroom house costs $100,000. Does that make sense? And for the average $400,000 house, let's do numbers that we can do in our head. So the average 4-bedroom costs $400,000. And we want to kind of get an equation going so we can look at what seems like a good value. So let's start setting up. The equation for a line is y equals mx plus b. Y equals mx plus b. So at one room, so first think to yourself for a little bit, which is the y value and which is the x value. In this case, for one bedroom, is x 100,000? Is x 1? Or would y be 1? Or would y be 100,000? So take a minute to think about that. Pause it if you need to, please. I'm about to blurt out the answer, so 3, 2, 1. So what I would do is I would set x as 1. So I'd be saying 100,000 equals m is unknown. We don't know that slope, although hopefully you can kind of guess it here. We picked kind of easy-ish numbers. And then x for this situation is 1 plus b, which is again the y-intercept. And I think I can guess that value too. Now what would the other equation be? So try to think about that for a second. What would the, because you have two unknowns, we've got m and b, so we need two equations here. Again, sorry for the audio. What would the other equation be? Try to think about that. Pause it if you need to. 3, 2, 1. So we're going to have a 400,000 for the y. I don't know what happened there. 400,000 and m, and then x for this situation is 4 plus b. Now if we start to solve this, hopefully what we'll see is that this is literally just 100,000. So this m is going to be 100,000, b is going to be 0, and we're going to have our ultimate equation of y equals m. Oops, no, there's 0 there. mx plus b. And what's kind of cool about this is you could go to some, like Zillow. You go to Zillow, don't use this equation, this is a bad equation, but you would kind of graph this out. And it would really look like this. I mean, it'd be a crazy, crazy slope if you just said 1, 2, 3, 4, you know what I mean? But we're going to say we're going to put one house, or 2, 3, 4 rooms, and we're going to call this 400,000 here. So we're going to have a graph like this. Now, what happens if you find a 2-bedroom house and they're asking $250,000? Is that a good or a bad value compared to these averages, right? So think about this. When you're graphing houses and you're finding the data, and you find a house that's here on the line, you find a house here, you find a house here, which of these houses are the best value? Would you want one that's above the line or below the line? And actually, would there really be a house with 1.5 bedrooms? But just go with me here, right? That doesn't quite make sense, because a bedroom is kind of an integer value. You're not going to have 1.5 bedrooms. So that doesn't quite make sense the way I drew the dots, but hopefully you understand what I'm getting at. Do you want, remember, this is the dollars, this is the Benjamins here, this is money. The higher you go, the higher the price. This is the bedrooms. 1, 2, 3, 4 bedrooms, even out to, say, 5 bedrooms, right? Maybe this will still hold true. So this is bedrooms. Do you want to buy a house that is above the line or below the line? Where's the best value there? Try to think of that. So if we're going to map this out, let me try to erase. Can I erase just some of these fake houses here that I made up? good enough. And then I'm going to get back to here. So let's say that we find a one-bedroom on the market for $150,000. Well, we know that this line is going through 100,000 here, so 150 would be, say, here. So here's one of the houses. Is that a good value? I don't know. All right, and then let's say we find a $200,000 house also for $150,000, so it's easier to draw. We find a 3-bedroom house for, say, $350,000. We find a 4-bedroom house for $300,000. Which of these houses is the best value? Which of these houses do you want to buy? So we can see that if we can expect houses to be at $100,000 for 1 bedroom, and again, made up numbers, this one's a bad value. So let's start changing colors here. Bad, 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 bad. This one's above the line. This is also a bad one. But let's say that you need a 3-bedroom and this is the only one. You might have to bite the bullet, buy that house. Now, if you got the money, the best value is this one, because look how far below our estimated average this house is. That one's doing pretty good. This one's a reasonable value too, and if you can't afford, maybe you can't afford this $300,000. Maybe you don't have that much money, in which case maybe that's the house to look at. Now, my wife and I did the same thing. We're both engineers. We're geeks, or are we geeks or nerds? I don't remember which. Please comment below. I'm not big into like Star Trek, Star Wars movies, although they're great and everything. But I'm more about like this sort of stuff. So anyway, which is the better value here? Try to think about that. It's this one, because it's so far below. And so what we did before, we did this with, we're looking for cars, and we did this with multivariable. This wasn't just a single variable of x. We had a more complicated equation, but we were looking at cars, and we're looking at the mileage. We were looking at the mileage for the cars. We were looking at the year. We were looking at whether or not this was a Ford, so whether or not it's titanium or not. So those are some of the things we were looking at. What else? Whether or not it had the 2.0 liter engine, or whether it had the engines that weren't as good. You know what I mean? So these are some of the things that we looked at. We made this kind of big graph and found all the cars we could, dumped all the data in, wound up with all these cars all over the... Actually, these should be the red ones, right? Because these are the ones that are above. You want the ones that are below, right? This is the sweet spot you're looking at. It's the stuff that falls below this curve. So anyway, I hope that made sense. This is another application of y equals mx plus b, real world example. You might be in school thinking, when am I ever going to use this? Well, if you're a geek or nerd like me, again, let me know. I don't remember which type it is, but here's a real world use, and we saved a couple $1,000s or whatever on a car, finding a good value. So this might be helpful to you. Anyway, this was Keith from Kinvert, and we will... Why am I waving? You can't see me. But anyway, we'll see you guys later. Bye-bye.